we're moving into a new unit, and we're going to start this unit off with a challenge question. Rather than telling you what this unit is or is about, I want to give you the opportunity to try thinking through something new that you're going to see that we haven't explored the possibility of before. And I want you to do this using an environment diagram, because what I think you'll be surprised to realize is that all the effort we've put into mastering these diagrams and understanding how a program is evaluated in memory will really help you here, such that there's nothing actually new that you will need to understand is happening if you just follow the same rules of the environment diagrams you've used up until now. Right? So pause the video at this moment to try and work through this problem. Okay, so what we're going to do is set up our globals, and in this example there are no globals that we need to worry about as far as we know right now. And then we have our main function, and the main function begins on line 14 is when that function call was encountered. We have no arguments to set up as parameters, so we jump into main, right? And so at this point, we reach a call to the f function with an argument value of 2, and 2 is being passed to the n parameter. And so what we're going to do is we're going to set up a frame for f, and the return address is going to be line 1. And we need to set up our parameter n, right? And so n is going to have a value of 2, right? So this is the argument that we're passing into the parameter n. It has a value of 2. All right, so we're in our function f, and we reach a print statement, right? So I'm going to set up some output. And the output column begins with printing n. And so we look in our current frame, and remember our current frame in the way that we represent these diagrams is the lowest frame on our stack that doesn't yet have a return value in it. So in this case, it's the frame for f, and n's value would be 2. So the first bit of output would be 2. Then we reach an if statement. If n is less than or equal to 0, that is false, right? N is 2. So we jump to the else block. And what do you know? We reach a function call. Just like we've reached function calls in the past. What do we do when we reach a function call? Well, we set up a new frame named f. And the return address here is going to be line 9. And we're calling this f function with a value of n minus 1 would be just 1, right? And so we're passing a value of 1 to the parameter n. Right? So what do we do when we set up a function call? Well, we pass in the parameters, we set up our return address, and we're ready to jump into this function. So sure enough, we jump to the top of the function named f, right? And so we're in this function named f, and we print n. Well, which frame are we talking about, right? Remember, the frame that we're currently working in is, again, the last frame that we added to our stack that has yet to return. And so here we're talking about the frame where n is 1. So when we print n, the value that is printed is 1. And we reach this return statement, or sorry, we reach this if-then statement. And if n is less than or equal to 1, well, if n is less than or equal to 0, well, n is 1, so that is false again. And we go to the f, the else branch, where we call f one more time. So what do we do here? Well, this is just another function call. We do what we always do when we reach a function call. We set up a frame on the stack. We're calling the function f. This time around, n was the value 1, so 1 minus 1 would be 0. So we're going to set up the n parameter as 0 and the return address as line 9. And we jump into the f function again, right? At line 5, we print n. Well, which n are we talking about? We're talking about the current frame that we're working in. Once again, that's the lowest frame on the stack that hasn't returned. And n in this frame is 0, so the output value is 0. We reach this if statement, and this time around, if n is less than or equal to 0 is true, and in this case n is 0, so it is true, we go into the then block. And in the then block, we print an exclamation point. All right, so we've got a different evaluation of this function f this time around because n was equal to 0. We skip over the else block, and on line 11, we print n again. So which n are we talking about? Again, this is going to become a bit repetitive, but I'm going to keep saying it because it's so important to tracing through what's going to be called a recursive function like the one that we're seeing, our current frame on the stack is the last one we added that is yet to return. We haven't yet set up a return value for this function. So we're talking about the frame where n is 0. So I'm going to print out another 0 here. And then we reach the end of this particular function. Well, this is a void function, so the return value is nothing. And we're going back to line 9. Well, where was line 9? Line 9 was where we called f with an argument of 0, right? That's what got us into this frame down here. But we just finished up that call to f. So what do? Well, after a line of code completes, you continue on, and we know that we reached the end of this if then else, so we reach this print statement again. But this time when we print n, we ask which frame are we working in, and remember now, because the earlier frame, that function finished and its evaluation was completed, so we've returned to the function frame where the value of n is 1, right? And so this is the lowest frame on our stack that hasn't yet returned, right? So this frame returned nothing. This frame is yet to return, and it's the lowest frame on our stack. So this is the one we're working in, and n is 1, so we print 1, right? And what do? Well, we reach the end of that void function, right? So this is the last line of that void function, so we return nothing from this void function. Where do we return that to? We return it to line 9, so the computer goes back to where it left its bookmark, where that call to f originated. And this was the call to f where we said f of 1, right? So this was what got us into this frame. But now the current frame that we're working in is this one, right? This is the frame we've returned back to on our stack. And so when we reach line 11 and we print n, n's value in our current frame is 2, right? And we reach the end of this particular stack on the frame. The return value is going to be nothing. And where do we return back to? We return back to line 1. We've just finished this call where f was 2 to f of 2, and now we've reached the end of main, and the return value of main is nothing. Okay? And so we've traced through this program using the exact same set of rules. There's no new rule that we've applied in this environment diagram, but there was a new dynamic, a new concept that we hadn't traced previously. And that's this idea that a function can call itself. And that idea is called recursion, right? A function can refer to itself from within itself, and it can be defined in terms of itself. And so this idea of a recursive function is one where you will see inside the function itself, it's going to call itself, right? And that can be an uncomfortable concept to become comfortable with in the early stages of programming. But one of the reasons why we spend so much time working on a diagram such as these is once we understand how a computer is able to interpret some code like this and how it is able to keep these 3 function calls to f separate from one another such that each has their own value of n in their own frame, so that when we go back and we return to these frames, we're talking about the variables that were still there. It makes sense, right? And so what we're going to spend some time looking at and diving into in much more detail in the following videos is how does this work? What are some of the rules that we need to know if we're trying to write recursive code to avoid infinite recursion? Just like we don't want to write infinite loops, we want to be sure that we avoid infinite recursion. And how do we generally think about this concept, and where can we apply it? So great work tracing this environment diagram out, and we'll move on to actually discussing recursion as a conceptual concept in this unit.